Okay, well, let's move on to the next slide and actually look at this graphically. An example of the hypothesis testing focusing on the distribution of sample means, assuming the null hypothesis is true. There are sample means that are likely to be obtained if the null hypothesis is true. That is, sample means that are close to the null hypothesis. And there are sample means that are unlikely to be obtained if the null hypothesis is true. And that is sample means that are very different from the null hypothesis. Now, and again, what's this likelihood business? Well, let's look at it. If we say that alpha is 0.5, that's going to weigh into this, or alpha of 0.1, etc. But let's focus on this graph. Here's the set of potential samples divided into those that are likely to be obtained and those that are very unlikely to be obtained if the null hypothesis is true. And here's where this tail business comes in. You can see, and I'm trying to adjust the picture here. Maybe this ain't going to happen. Nope, apparently not. That the middle ones are close to the null hypothesis, and that's quote unquote high probability values if the null hypothesis is true. Now, what do I mean by high probability? If alpha were set at 0.5, that white space there, and I'm going to try to float my cursor around it, like right here, would be the middle 95% of sample means. These orange spaces are a combined 5%. And what does that mean? That means there's 2.5% in each tail. Now, we can't know whether it's going to be a very low sample mean or a very high one because either of those is inconsistent with the null hypothesis and therefore would lead to rejecting the null hypothesis because this is a two-tailed test. So this middle section here is the middle 95% if alpha is set at 0.05. Now, again, that leaves a total of 5% over here in the orange spaces. And if you break 5% by 2, divide by 2, that's 2.5% in each orange space. Now, you could say this is arbitrary. Likelihood, unlikelihood. What's a hot day? What's an old person? Is an old person 85 or 62? Depends on your age, I guess. And by the same token, by widespread convention or mutually agreed upon number, is that if it falls outside the middle 95% in a two-tailed test, we'll call that unlikely. Or pardon me. Yeah, exactly. If it falls outside that middle 95%, that's unlikely. So that's these orange spaces. If it falls within this big white space here, then that's likely. The implication would be if I got a sample mean that was out here or out here in a two-tailed test, I would essentially say that the null hypothesis is unlikely to be true, and I will reject the null hypothesis. Conversely, if I found a mean in this middle white region, I would say it's not particularly unlikely that the null hypothesis is true, and I'll go ahead and accept the null hypothesis. And more specifically, I should say, it's not particularly improbable that I would have gotten a sample mean that falls in here, given that the null hypothesis is true, and therefore I will accept it. I'll fail to reject the null hypothesis. Again, there's arbitrariness in this. There is. Where did we get the drinking age? Where did we get the voting age? 18 and 21 respectively, etc. Although they kind of make sense, arbitrariness is leaked into this process, no question about it. So we'll get to this more mechanically here shortly. So here we go. We're going to mark the distribution of sample means for levels of alpha, assuming that the null hypothesis is true. You can see over there on the right, with rare exceptions, the alpha level is never larger than 0.5, and again, the great majority of the time it is. To find the boundaries that separate high probability samples from low probability samples, we got to define what's meant by low and high. This is accomplished by setting a specific probability value known as the level of significance, or alpha, for the hypothesis test. The alpha value is a small probability, never more than 0.05, that's used to identify the low probability samples. By convention, and what they mean by convention is just widely agreed upon number in this case. So I think in all 50 states now, although it was different in the 1980s, the drinking age is 21. When I was young, the drinking age was, I think, 19 in Wisconsin and Ohio or something silly. But because we're just all on the same page, is what that means. The commonly used alpha levels are 0.05, 0.01, and in rare cases, 0.001. But with 0.5, we separate the most unlikely 5% of sample means from the most likely 95%. And again, that's in this two-tailed example, that falls in this white space. as a researcher, I don't want it to fall in the white space. I'd prefer for it to fall out in the orange space so I can reject my null hypothesis. I know I'm running a little bit long, but let me just read this last phrase and we'll get on to a concrete example. The extremely unlikely values as defined by the alpha level make what's called a critical region, and that was these orange regions before. These extreme values in the tails of the distribution in a two-tailed test define outcomes that are not consistent with the null hypothesis. They're pretty far apart if you assume the null is true. So whenever the data from a research study produce a sample mean that's located in that critical region, we conclude that the data are not consistent with the null, and we reject the null hypothesis. Now here's the thing. Might the mean in that distribution of sample means wound up out here or here by chance? Yes. And if it did wind up here or here by chance, would we reject the null hypothesis? Yes. And is that an error of sorts? It is an error of sorts. And we'll talk about that later, but that's a type 1 error, which can't be avoided. It just is what it is.